Okay, so before we start with our topic, we have two topic left. This is the second last concept in linear and angular kinematics, and the final topics will be regarding concept in linear and angular kinetics. Tu terakhir lah. So before we go there, let's see this one first. Okay, now we are at week 10. Okay, concept in linear and angular kinetics, and we are going to um, discuss about another topic next week lah. So week 11, you're going to have your first test next week. Okay, and this test will cover chapter 1 until chapter 3. So chapter 1 introduction. Okay, and then chapter 2 we have anatomical basis of human motion, and chapter 3 is regarding bone, joint, and muscular system. To be exact, it is regarding bones. Okay, itu tiga benda yang kamu akan diuji pada minggu hadapan. That is the first one. So please read through chapter 1 until chapter 3. Okay, ni chapter 1, chapter 3 ni your quiz 1 dulu. Jadi test 1 is quite similar as quiz 1, except that it is going to be much longer compared to before. Alright, so secondly, I want to remind you about this thing, group presentation and report. Okay, yang individual ni kamu dah settle up, which is regarding your journal review. And for the group presentation and report, this is a reminder. Okay, what you need to do is actually you need to do a spot skill video analysis. Okay, and what are the things that need to be analyzed is what we are going to learn this week and next week. Kinetics, kinematics. Other than that, you also need to include all those that we have learned earlier. Example, the muscle use, the joint, the bones, the movement plane, all of the things that we have learned from week 1, you need to include in your sport skill video analysis. Jadi tu bahagian introduction lah. Okay, bahagian introduction ni benda kita dah belajar sebelum ini. Intro about the skill. What sport skill do you intend to present? Movement of the skill in terms of biomechanical. The terms, all those positioning terms, superior, inferior, flexion, extension, all of those things need to be included in the introduction part of your analysis. Okay, in the introduction part. Ni semula ni, task analysis, movement performance criteria, mechanical basis of human motion, ni Newton law. What Newton law involved in the movement itself. For example, kicking a ball. So you are going to talk about Newton first law, inertia. The ball is not going to move unless it being given a force. And then when you give a force to the ball, it causes the ball to move. In which direction, in which properties, all of those things is underneath the type of motion. And then you need to include within the introduction itself a fragment photo of the sport skill being conducted. Means pictures of the sport skill being conducted. You may present, you may actually have what we call it, in terms of pictures, or you may have it in terms of your videos. So untuk write up pictures lah, pictures of the skill being executed, but in your presentation it need to be a set of video. Okay, that is the introduction of the skill. Okay, and then for the main gist or the body of the presentation, you need to have step for maximizing skill performance. Means here you need to explain about kinematic, about the kinetic, about the summation of force, about the impulse momentum, about the technique of skill performance, all of those things that you may have from the analysis. Ni benda yang kita akan buat pada minggu ini dan minggu hadapan, if possible. If not, we are going to continue. Okay, jadi benda yang kita belajar minggu ni dan minggu depan is actually the main gist of biomechanics. Apa analisis biomekanik yang kamu boleh buat. And finally, you need to conclude your presentation and your write-up by summing up all those points that you have presented earlier. This is the reason why the performance become like this. In order to become better, we need to do that. That will be your conclusion. So you're going to have group presentation and also group report. Okay, and this presentation will be conducted via video presentation. Means you need to record your video presenting this assignment and upload it into YouTube before attach the link in your assessment later on. Okay. So menatang-menatang ni kita tengok bila dia kena submit. Okay, let's go back to the scheme of work. Take a look. If you take a good look here, kamu akan ada video recorded group presentation and written report to be submitted on week 12, which is another 2 weeks. Is it possible for you to do so? Again, what you need to have is main gist dia kita start kat sini ni, linear and angular kinematics, linear and angular kinetics. Jadi my assumption we are going to finish all of this by week 12. Okay, so I'm going to move this submission to week 13. Okay, saya akan pindahkan semua submission ni ke week 13. Kalau ikut sini, we have video analysis presentation, but since the presentation will be conducted via recorded, so week 13 will be the deadline of your submission, both presentation and also written assignment. Boleh? So, kita ganjakkan seminggu lagi. Can we do that?
Alright, sir.
Yes, sir.
Boleh, sir.
So we have 4 weeks or we have another month to finish up the presentation. Okay. My advice is you start now. I know that most of you does not start anything at all. Start now and start doing the introduction part. So you may have presented, you may have the draft, you may have the written assignment regarding introduction, regarding bone, joint, regarding anatomical basis of human motion, regarding for the sport skill that you have chosen, and then you can actually explain about bone, joint, and muscle involved in the execution itself, and you may stop at the type of motion. Motion macam mana? Kalau kata bola sepak, what is type of motion? The movement itself is general motion, and the ball travelling is actually linear. Boleh cerita lah benda-benda tu. Okay. So that is regarding your final presentation and also report. Okay. Now let's go to our second last chapter, which is regarding concept in linear and angular kinematics. Okay. So let's move on. Before we go further, before we go to the every single properties in the kinematics, these are the definition of kinematics: study of geometry, pattern or form of motion with respect to time. Okay, bahasa kampung kinematik ni pattern. Okay, example. Okay, let's take this example. Okay, let's say we have a soccer player try to kick the ball. Okay, jadi dia akan ada satu pergerakan begini, and it will hit the ball, which in return will make the ball travel. Okay, pergerakan menyepak bola. So, in pergerakan menyepak bola, we are going to have two things. One, the thing that we can observe, pattern. Kaki dia hayun ke belakang, kaki dia hayun ke depan. How fast, okay? How fast this movement occurs, the velocity of this movement, how fast the acceleration of this movement, and then how far in terms of meter, okay, ataupun range of motion. All of these things that we can observe regarding the execution of a ball being kicked is known as kinematics, ataupun pattern of the action. Ini yang kita akan belajar minggu ini. Pattern of the action. Okay. And the ball travel. Kita boleh nampak bola tu terbang. Bola tu melayang. How fast? Okay. Velocity of the ball. how fast acceleration of the ball, pun kita boleh cerita. So in a kicking action, we can actually describe the action of kick itself and also the byproduct of the kick, which is the ball driver. All of this means the thing that we can observe, we can actually see, we can actually describe is known as kinematic, pattern of action. Tapi kalau kita cerita kaki ni laju, kenapa dia bergerak selaju itu? Means we try to describe regarding contraction, muscular contraction, how much force being produced. When we talk about this thing, this sole thing, this is known as kinetics. Okay, bila kau nampak kinetics ni, kinetics also refer to motion. So, a branch of biomechanics which deal a lot with kinetics is a branch that deal with the cause of motion. Cause dia. Jadi apa cause of motion? Force. Okay, so when we describe all of those properties of force, this is a sub-branches of biomechanics known as kinetics. And we have when we have kinetics, when we have force in a system, it will cause movement. It will cause something to appear. It will cause a pattern. All of those things, pattern, movement, okay, character, thing that can be described, thing that can be seen is known as kinematic pattern. Okay. Kalau kata kita ambil contoh let's take an example here. Yep. Okay. If we take this one. Okay. Ni. Benda yang kita boleh cerita. Apa? What can we describe regarding these pictures? What can you describe regarding these pictures? Hi, hello. Anybody?
Kicking action.
Kicking action. Okay, apa yang kita boleh cerita tentang kicking? Berapa tinggi? How fast this fella kick? Okay, what is the acceleration of the leg? All of those is pattern. Dia tembak, dia sepak tinggi. How about this one? He try to avoid. He try to play defense. Maybe try to walk backwards. All of those things can be described. Itu kinematics. Tapi kalau kita cerita dia sepak ni kuat tak kuat? How hard does this kick? That is force. Itu kinetics. Can we see force? Boleh tak kita nampak force kat sini?
Tak boleh je.
Tak boleh. Okay, tak boleh. So, in other words, when we talk about force, it is we can describe, we can measure, but it cannot be observed. Kita kena measure dia. Tapi kalau kinematics, we can actually observe the movement. Laju tak laju. Ni dia sepak tinggi tak tinggi. Means displacement ataupun distance. That is the difference between kinetics and kinematics. So for today, we are going to talk about kinematics. Okay, study of pattern and geometry. Kinematics span both qualitative and quantitative. Biomechanics commonly use high-speed cinematography, high-speed photography in order to quantify kinematic analysis. Okay, so kinematic analysis, when we talk about kinematic analysis, in biomechanics, the main kinematic analysis we have is this one. Kinematics properties. Okay, when we talk about kinematic properties, we can further divide that into two major groups. One is linear, one is angular. Do you still remember the type of motion? How can you define linear? How can you define angular? Ingat lagi tak kalau kata kita ada benda macam ni? Kita ada track tegak and then curve. Okay. So, soalan saya. Daripada point A ke point B, what kind of motion is this one? What type of motion is this? Ni. Okay.
Linear.
Apa ni? So, sorry, again.
Yeah.
Linear. Okay, kalau kita ambil B ke C, ni.
Angular.
Yeah, salah. Still remember this one. Ini benda yang kamu buat quiz malam ni. Satu nama dia curvilinear. Satu nama dia rectilinear. A to B is known as rectilinear since it is straight line. But B to C, curve kan, ambil lap. This is what we call a curvilinear. Okay, kata ambil C to D pula. Nampak? Another lap. This is curvilinear. D to A pun lapping. Curvilinear. Because of what? Because it's still in one line. Means it start from A, it goes straight according to the line and go back there. When we talk about angular, you miss out one point, which is you need to have an axis of rotation. Kena ada axis of rotation. In other words, when we talk about angular motion, motion dia macam ni je. Macam tu je. That is angular motion. This is angular motion. This is angular motion, where it start and end at the same point. It just involving a rotational action. Itu angular motion. Okay. So, kalau kita tengok dekat gambar ni, kaki ni kalau dia nak menyepak, okay, let's say kaki ni dekat bawah, so it will goes up and down, up and down. Because the motion of the leg is originate from the axis of rotation here. The head of femur dekat pelvic kamu. Okay. Which make the motion at this axis only. Femur kita ni, dia tak boleh keluar ke sini. Dia tak boleh naik ke atas. Dia tak boleh ke bawah. It can only rotate. Itu angular motion. Okay, that is angular motion. Rotation at the femur. Okay, however, if we take a look at the pictures before, again, if we try to explain, katalah ni kaki dia dekat sini, feet if we try to explain the movement from bottom, top, how far, that is linear. Tapi kalau kita cuba cerita the whole complex, the rotational, that is angular. Dia nampak ni kan? Dia ialah angular. So try to differentiate. First, when we try to, somebody please turn off your mic. Okay, when we try to explain about kinematic, we need to differentiate linear and angular. Case macam ni, case linear. Case rotational, where you have an axis of rotation, that is angular. Okay, case yang tak ada axis of rotation macam ni, it is linear. Either curvilinear ataupun rectilinear. Kalau linear dia tegak, like this, rectilinear. Tapi kalau dia melengkung, ambil lap macam ni, this is curvilinear. But if the lap is something like this and you know it is an axis of rotation, this is angular. Ni, kena tengok benda ni. Ada tak axis of rotation? Okay. For example, if we try to rotate your palm, okay, kita buat rotation dekat palm. Ni angular. Because you have an axis of rotation at one point. If you try to move your elbow, flexion and extension of the bicep, that is angular because the elbow serve as the axis of rotation. If you move forward, that is general because you need to have movement at the axis of your head, of your leg, of your ankle, of your hip, and the movement forward itself is linear. So combine those two become general. Okay. Now, for both linear and angular type of motion, there are three different properties which we can describe under kinematics. One is displacement, where we talk about change of distance. Ni yang pertama. Two is velocity, where we talk about rate change of distance. And the last one is acceleration, where we talk about the rate of velocity change. Ni adalah tiga benda. So these three things, displacement, velocity, and acceleration, can be described in both linear and angular. Dia boleh cerita dalam dua-dua itu sekaligus. Okay. So the first one is distance and displacement. Dia ada dua. Distance and displacement. Okay, apa beza distance and displacement? Both of this one is measuring length. Okay. Both of this one, we are going to measure in meter. Okay, in meter. In SI, meter. Jadi kalau kamu dapat kilometer, change to meter. Kalau kamu dapat sentimeter, change to meter. Unless all of the length in that particular problem being described in kilometer, biarkan. Tapi kalau dia bercampur-campur, better change it first to meter. So now, what is the difference between distance and displacement linearly? Okay. Kalau kita tengok gambar ni, this fella, dia bergerak ikut garis dot-dot ni. Dot sampai sini. When we talk about distance, distance is how far this player travel, and you need to measure it along the pathway. Melengkuk-lengkuk ni. Katalah jauh dia bergerak ni, ikut lengkuk ni, 40 meter. And when we talk about displacement, displacement can be can be defined as change of distance, change of place. It come from the root word displace. Jadi kalau kamu ada dekat sini, A, and then later kamu ada dekat B, this is what we call displace. Okay, berubah tempat. Kalau kamu ada dekat A, and then suddenly kamu ada dekat C, this is what we call displace. Okay. Macam mana dia bergerak? Mungkin macam ni. Mungkin macam ni. So displacement, we care about how far. And this far being described as the straight shortest line between start to end. Dia takkan ikut pathway. Dia akan ambil point yang tegak daripada point start ke point end. Satu garis lurus. That is displacement. So, by that definition, if let's say we have A, and we move along the way here, there, and everywhere, and return back to A. My question, is there any displacement in this particular movement? Ada displacement tak? Ada perubahan tempat tak?
Tak ada, sir.
Tak ada. Jadi displacement dalam case ni kosong. Ada distance tak? Is there any distance travel?
Ada.
Yes. There it is. Jadi kalau cerita distance, kita kena ukur along the way, along the pathway. From point start to point end. But displacement, okay, katalah kita ada displacement macam ni pula. Okay, kita ada track 400 meter. Okay, saya akan bagi kepada 4 bahagian. So we start here. Go to the first 100 meter. My question, what is the distance? Kalau dia gerak daripada sini ke 100 meter, what is the distance? Distance will be 100 meter. How about the displacement? Berapa displacement dia? Daripada start ke 100 meter. 100 meter. Straight line. This is 100 meter chord. So the first 100 is straight. Maksudnya kalau dia straight line, it will be similar as the distance. Okay, now, if the runner continue to 200 meter, what is the new distance? Berapa distance baru dia sekarang? Tadi 100, sekarang it become how far? How far this runner run?
200.
200. Displacement dia? Okay, displacement dia jadi macam ni. So, these are the start, these are the end. Jadi, kita akan buat satu line daripada start ni ke end. Satu line lurus yang paling pendek. Zaz. So, berapa distance dia? Okay, untuk distance yang ini, we need to find out dia punya resultant. Jadi, kamu kena adalah data ni. A, B. So, R equals to A square plus B square. R equals to A square plus B square square root. Dapatlah dia punya berapa jarak dia. Maksudnya jarak dia takkan sampai 200 lah. Okay. So, the displacement here is less than 200 meter. Pasal dia adalah jarak lurus. Okay, now let's see the runner continue running to 300 meter. Now the distance will become 300. However, the displacement ni 300 ending dia ke permulaan in one straight line. So kita dah ada R tadi, tak carilah ukuran kat sini pula. So ukuran dekat sini most of the time is going to be less than 100 lah. Dia pasal dia straight line. Kalau kata runner tu continue running again 400. So the new distance is 400. Displacement now is 0 because it is as similar as the starting point. Means that there are no displaced. Tak ada berubah tempat lah. Dia berada pada tempat asal dia balik. So the displacement is 0. Okay. So ni adalah perkara yang pertama, which is linear distance and displacement. Okay. So why we have both distance and displacement? Kita tengok sini kan. Kita ada distance, kita ada displacement. Kan dia benda yang sama. Alright. So distance and displacement are assessed differently. Distance measured along the pathway, but displacement measured in the straight line from position 1 to position 2, or from initial to final. And why we have both distance and displacement is because of this thing. In physics, we have two types of what we call it. Can we call it as measurement? Okay, one not measure unit. One is known as scalar unit. Another one is vector. Okay, distance dekat sini, displacement dekat sini. So what is the difference between scalar and vector? The major difference is when we talk about vector, vector has magnitude, vector has direction. Ini yang paling penting. Okay. Use scalar unit, dia ada magnitude je. Okay, apa itu magnitude? Okay. 400 meter tadi. Alright, 0, 100. This is what we call magnitude. How much? Okay, how much? Katalah kamu pergi supermarket, lepas tu main yang mesin pancing tu naik 900 Newton. That is how much. Itu magnitude. So scalar and vector both have magnitude, but vector dia ada direction. Bergerak 100 meter. Okay, bergerak 100 meter. Tapi, we can describe that in term of plus 100 ke atau negatif 100. Means, we can describe in term of direction. Okay, so to what we call it, to understand direction, we are going to use coordinate. Okay, nama koordinat ni Cartesian coordinate. Oh. Cartesian coordinate. Okay, so kita ada X, kita ada Y. Ni zaman sekolah tu dah belajar ni, X dengan Y paksi. Okay, so any movement, later on kita akan tengok contoh, any movement that move from left to right, the value will be positive. Jadi lawan dia, any movement that from right to left, it will be negative. Same goes, anything that move from bottom up, this is known as positive movement, and anything move down is known as negative movement. Okay, so mesti kamu familiar dengan nombor ni. Tolak 9.81 meter per second square. This is the figures of acceleration ataupun figures of gravitational force. Okay, apa sebenarnya yang nombor ni cakap? It talks about two things. One, negative. Means we know that gravitational force move or pull us downwards. So this negative actually representing ini. We know that gravitational force pull us to the ground, ke bawah. Maksudnya gravitational force ni dia bergerak macam ni. Gravitation ke bawah. It not upwards, it not forward, it not backwards. It works downwards. And that is the first meaning of negative. Ni Cartesian coordinate. And the second one, based on these figures, the information that been given to you is ni. 2. Okay. Superscript 2 means it gives you information that these figures representing a value of acceleration. Okay, so bila kamu nampak ms2 acceleration, kalau dia just letak ms, tak ada, maksudnya satu lah. Ini velocity. Jadi kita tengok. Okay, jadi daripada nombor ni, negatif 9.81 meter per second square, we know this is a value of acceleration and we know the acceleration is downwards. Katalah dia bagi kamu lagi satu, 10 meter per second square. Okay, now what does it means? Square. This is a case of acceleration. And then depan tak ada apa-apa, maksudnya dia positif. When we see this thing, it may have two meaning. Satu, mungkin acceleration tu ke kanan. Satu, mungkin acceleration tu ke atas. So it depends. You need to read through the problem first. Tapi inilah maksud dia. Okay, another one, when you see a positive acceleration, it also means this is a case of acceleration. Kalau negatif 10 meter per second, this is also a case of deceleration, memperlahankan perjalanan. Yang ini melaju. Okay, this is increasing in speed, positive. Kalau kita nampak negatif, this is a case of decreasing in term of speed. Ini beza skala dengan vektor. So the first skala and vector you have is regarding distance and displacement. And this is an example of linear case. Okay, linear case. Okay, angular case. Contoh, kita ada benda macam ni. Let's say kita ada kita tengok contoh angular displacement dengan jump. Alright. In linear, we measure displacement and distance by using meter. In Angular, we measure displacement. We are measuring displacement and distance in Angular by using degree. Maksudnya kita akan tengok dia punya angle. Okay. And we also measure displacement and distance in Angular in terms of radian. Okay, recap. In one full rotation, if we start here, we go a full rotation. We end at the same place. One full rotation consists of 360 degree. Ini kita panggil sebagai satu rotation ataupun satu revolution. So 360 degree can also be described in terms of 2 pi radian. Ini semua benda ni sama. Okay, where 1 radian equals to 57.3 degree. Okay, ini asas. Okay, kenapa 1 radian 57.3? Simple. Saya bagi reason simple. If we go for a slice which has a theta, okay, theta dalam fizik representing angle, which has a theta of 57.3. At this point, radius 1 akan sama dengan radius 2. Semua orang tahu. And ini pun ialah radius of rotation. Kita panggil radius 3. So at this angle, R1 will equals to R2 will equals to R3. Itu sebab 1 radian 57.3. That is a simple reason why. Okay, now let's go back to distance and displacement in term of angular. Okay, linear tadi, kalau kita ada pergerakan macam ni, kita akan measure from point A to point B. Berapa meter? This is linear distance or displacement. But in term of angular, what you are going to measure is, let's say, you have something that start from pukul 12 lah, and it move to pukul 3, where we know that the angle here is 90 degree. So the displacement or the distance covered, katalah jarum panjang ni kan, oleh jarum panjang ini, which move from 12 o'clock to 3 o'clock is 90 degree. Ini cara kita measure distance or displacement in angular. We measure in term of degree. So if the clock hand further travel to 6 o'clock, another 90 degree, the distance covered now is 180 degree. Dah tak ada meter dah. Kita describe dalam bentuk angle. And if the clock hand further travel to 9 o'clock, now it has traveled 270 degree. Now issue coming from. These are the distance. How about the displacement? The definition is still similar. The shortest way. Jadi, kalau kita nak tengok displacement, kalau kata tadi jarum ni start sini, habis dekat sini, the displacement is not 270. But it is sini saja. 90 ke kanan. So, it will be 90 degree. That is the displacement. Okay. Kalau kata tadi jam tu berhenti dekat sini, displacement tetap 90. Kalau jam tu berhenti kat bawah, displacement 180. Tapi bila jam tu teruskan perjalanan 270, now the displacement, this one is become much shorter compared to others. Ini distance and displacement. Okay. In real life, in sport life. Okay, katalah you have a person. Okay. So kaki dia start dekat sini. Okay. Since hip ni kita tak ada apa-apa reference, so we are going to draw one straight line, and we are going to use this as the angle. Okay. So kita namakan, kita assume angle ni. Okay, kita assume angle ni. Sekarang, okay, we assume this is the position 0. Okay, kita assumption. Ini adalah pergerakan 0. Okay, and then to kick a ball, leg ni tadi, dia akan tarik ke belakang. Zaz. Okay, and then, tadi dia start dekat sini. This is 0. Okay, now, let's assume dia tarik ke belakang ni, the angle is 220 degree. Okay. And when he try to kick the ball, the end place will be similar as the starting place. Kosong. Okay. So we start from kosong degree to 220 degree, and then it become kosong again. To measure angular distance or displacement, how far this leg displaced for one full kick. Jadi kita akan ambil kosong hingga 220, means dekat sini kita akan ada penambahan 220 degree, and daripada 220 jadi kosong, means that we have another 220 degree. 220 degree ke belakang, 220 degree ke depan. So the leg distance, in order the leg move in order to kick the ball is 440 degree, both back and forth. Ni jarak ni. So jarak in angular distance being measured in terms of angle. How far the accumulation of the angle. Tapi kalau soalan dia, what is the displacement of this leg? Berapa displacement dia? Berapakah angular displacement of this leg? It starts at 0, it ends at 0. So, how much is the displacement for this leg? It become kosong. Tidak ada displacement. Why? Because it start and end at the same place. So there are no angular displacement. Jadi angular, bila kita cerita angular, sebenarnya kita cerita rotation dia dekat bahagian itu. That will be the distance. Okay. Alright. Now, let's say kita ada bola. We kick the ball, which cause the ball to roll. Katalah bola ni roll 10 kali. Okay. So my question, the first question, what is the distance covered by the ball? Okay, berapa banyak angular distance dia? Number 2, berapa banyak dia punya angular displacement? Okay, berapa? Ni simple. If one rotation is 360 degree, 10 rotation, it will become 3600 degree. And the displacement, if the rolling is actually 10 full rolling, the displacement is 0. Kenapa? Okay, pasal katalah kita ambil satu point A, sekali roll dia balik tempat asal, 2 kali roll dia balik tempat asal, 10 kali roll, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, A will still become A. Means the place does not change. So, the displacement will become 0. Distance kita kena ikut berapa kali dia rolling. Okay. Katalah kita buat leg swing, 10 kali leg swing. Okay. So, our leg start here. We name it as 0. And then the swing backwards, it become 190. And then it swing backward. And then it swing forward again, stop at the same place. So, satu swing. So, one full swing is swing back and swing forward. So, 190 times 2 become 380. Ini distance covered by hip untuk satu swing. So, if the swing is 10, it become 3800 degree. 10 kali swing. Ini angular distance. Berapa angular displacement? Start and end at the same place. The displacement will become 0. Okay. Dapat. Satu properties. Distance and displacement dulu. Do you get it? Ni simple tu. Alright. So, we take 5 a bit and afterwards we are going to continue with second properties which is angular velocity. Angular and linear velocity. Kita sambung kepada properties yang kedua which is speed and velocity. So, these two is actually similar as the first one where we have distance and displacement. Jadi, speed ni scalar and velocity ni vector. Okay, again, when we talk about speed and velocity, scalar and vector dia ada direction. It has positive, it has negative. Okay, where positive means it move to the right and negative means it move to the left. Okay, example dia macam ni. Mana sini. Okay. Okay, this is the example. If we have two objects like this, object A, we name it as object A and object B. So object A move here, object B move there. So velocity sini, it will become positive. Let's say lah, positive 2 meter per second. And velocity sini, it will become negative 2 meter per second. When you see something like this, it show the direction of motion. Where it goes. Katalah lepas tu dia pun berlanggar. And after berlanggar, the new velocity is negative 1 meter per second. So we know that after the collision, the movement change direction to left hand side. So this is velocity and the direction which play a role in determining which way it goes. Okay, to velocity. Okay, let's take a look at the notes. Okay. So two quantities that parallel with distance and linear displacement is speed and linear velocity. The rate of change in location. Tadi kan kita ada point A to point B. How fast it go. Itu linear velocity. Okay. And in metric system, the most commonly used is meter per second. Tapi kalau unit besar, we go for kilometer per hour. So in order to find speed and velocity, these are the formula for it. Okay, velocity equals to displacement over time. Okay, velocity equals to displacement over time. Speed pun sama. Cuma speed, dia bukan displacement lah, dia distance. Itu je beza. Okay, if we go with speed, this one, S, equals to distance over change of time. Velocity V equals to displacement over change of time. Ni change of. Okay. Kita tengok contoh. Alright. Okay, kita ada dua macam ni. Okay. Alright, let's say. Sebelum tu saya tak formula ni. Okay, so we have speed equals to distance in meter over time in second. 4 meter per second. And that is what makes the unit of speed, meter per second. Meter bahagi saat. Ataupun it can be written as meter kali dengan saat. Meter per second. Tapi kena ada negatif. Which means that this second is actually at the bottom. Kat bawah. Okay. And for velocity, speed S. Velocity V equals to displacement in meter over time in second. V equals to apa value dia, meter per second. Sama juga. It can be written as meter times second. Negative 1. Jangan lupa ni. Kalau kamu nak letak macam ni. Okay, kalau kamu nak letak meter over second, tak perlu negative 1. Okay. Alright. So example, we take 400 meter tadi. Okay. Let's say this fella run from point A to point B. So the distance is 100 meter and the time taken is 11 second. Kita namakan ini sebagai section number 1. Okay. In section 1, the speed, okay, kita namakan dia speed 1 equals to 100 meter over 11. Ini cara dia. Okay, 100 meter over 11 second. So how fast is the speed? 11 over 100 over 11. So it become 9.09 meter per second. Since this is a straight cases, velocity is the same value, 9.09 meter per second. Dia akan dapat velocity yang sama value dia because it is a straight line. Okay, next, the same fella continue running to C. Okay, from A to C, which give a different distance. Let's say this one takes 13 seconds. Okay, 13 seconds from A to C. So kita namakan dia section 2. So speed for section 2 is 200 meter. Tak boleh ni, 13 sangat, terlalu cepat. 11, 23 saat lah. Okay. 23 saat. Kalau macam tadi boleh, bukan tak boleh. Okay, 13. Alright. Now, the distance is 200. The time, 11 campur 13, which is 24 second. Okay, berapa kita dapat? Dia punya speed over 24. 8.33 meter per second. This is the speed for second section. Okay, for 200 meter. Okay, displacement dia, yang ini ada tricky sikit. Equals to, displacement pula. Velocity dia equals to displacement bahagi dengan time. Okay, velocity. Displacement over time. Now, the displacement is this one. Thus. Okay, berapa R ni? Let's assume this one kita dah tahu 100 meter. Yang ini kita assume jarak dia lebih kurang dalam 70 meter. So, what is R? Okay, so displacement ataupun R equals to 100 square plus 70 square and square root of it. Ni adalah formula teorem Pythagoras, okay, yang mana kita ada benda macam ni. A, B, C. So, A square equals to B square plus C square. A equals to B square plus C square square root. Okay, revision. How you have this one is based on this theorem Pythagoras. So A 100 meter square, B 70 meter square, and we can find R. Okay, jom kita cuba. 100 square campur dengan 70 square, square root. Square root. Okay, so macam betul. 100 square plus 70 square 14,900 square root. Okay, 122.07 meter. These are the displacement, okay, between A and C. Jadi kalau kita nak cari velocity dia, velocity equals to displacement 0.07 bahagi dengan masa. Masa tetap masa yang sama, which is 24. divide with 24, we have 5.08 meter per second. And you're going to notice that the time will become, the velocity will become lesser compared to the speed because the distance covered is lesser. Okay, if we proceed, the runners proceed to 300 meter. And now the time taken from 200 to 300, let's say 12 seconds. Okay, so kita ada speed equals to 300 meter over, okay, berapa masa dia? 11, 13, 24, 24, 12, 36 saat. And the new speed is 8.33 meter per second. Okay, how about this velocity? Velocity equals to, okay, berapa distance terbaru dia? Ni. From point A to point D, 70 meter. 70 bahagi 36 saat. Dapat 2 lebih sikit je. Tak sampai 2, 1 lebih
1.94.
1.94 meter per second square. Meter per second. And finally, speed terakhir ialah 400 meter. Okay, ni yang terakhir. Tambah lagi 1 jadi 400. Okay, let's say dekat sini dia laju sikit 11 saat. So, 36 tambah 11, 47. Okay, berapa yang ni? 8.5 meter per second. And how about dia punya velocity terakhir? What is the final velocity? Since it return back to originate position, the displacement is 0. Jadi velocity dia tak ada. Ni adalah speed and velocity. You are going to notice that the speed and velocity keep on changing accordingly. Because when we talk about speed, it is the what we call it, the actual distance divided by the time taken. But when we talk about velocity, it is the displacement. Jadi kita kena cari displacement dia lah, the straight pathway, the shortest straight pathway from start to end, and divide with the time that you have according to the system itself, and then you're going to get dia punya velocity. Okay. Okay, contoh, kita bagi contoh dalam sukan. Let's say kita ada satu bola. Okay, kita ada satu bola. We kick the ball. Okay, and the ball travel. We don't know the velocity, x. Okay, but this ball travel for, let's say, 30 meter. Okay, the distance is 30 meter, and the time taken for the ball to travel this 30 meter is 1.5 second. So the question is how much, or what is the velocity of the ball? Okay, kat sini dia bagi distance. Since it is a straight line, distance displacement sama. Jangan risau. Tapi kalau dia kata case tu curve case ke apa, distance and displacement is quite different. If it is a rectilinear case, ni sama, tak perlu risau. So V equals to distance over time. 30 bahagi 1.5. Apa kita dapat? So these are the velocity of the ball being traveled. Okay. Okay, katalah yang kedua pula. Case yang sama lah, kita ambil netball. Kita ambil netball chest pass to player. Okay. If this ball travel at 10 meter per second, okay, at 10 meter per second, and then the ball airborne for 1.8 second. The question is, how far does the sender stand between the receiver? Berapa jauh jarak antara orang A dengan orang B? Ataupun how far does the ball travel? Samalah formula yang sama. V equals to distance over time. So we have V 10 equals to distance over 1.8. Jadi kalau nak distance je 10 times 1.8. So distance is 18 meter. Ni antara penggunaan untuk velocity. Okay, velocity and distance. Okay, let's try another one. Okay, we have an arrow. We have an arrow flying. Okay, to a target situated 50 meter from the arrow. Okay. Okay. If the arrow travel at a velocity of 120 meter per second, the question is how much time needed for the arrow to reach 50 meter? Berapa masa untuk arrow ni kena ke target? Time. So, you're going to use the same equation, d over t, where we have 120 over 50 t. Jadi t dia berapa? Berapakah t itu? How much t?
$2.4 second ke sir?
2.4.
4. 120 bagi 50 eh.
120 bagi 50. 2.4 second. Ya, betul ke?
Ikut.
Ya kot. Okay, kalau
0.417.
ya, kalau 2.4, okay tengok kenapa saya kata bukan 2.4. Senang je kalau kamu rasa was-was sangat. You have T 2.4. Now, try to substitute back dekat sini. Dapat tak 120? V equals to, distance kita dah ada 50 bagi dengan 2.4. Agak-agak dapat tak? Bagi 2.4. Bang. Tak dapat. Takkan dapat 120. Jadi berapa 120? Berapa T dia? 0. Berapa tadi? 0.417. Yes. So jawapan dia ialah 0.417. Macam mana dapat 0.417?
50 dibagikan dengan
Bahagi
120.
dengan 120. Yes. Bukan 120 bagi 50 It is not direct conversion. Tengok, bila kamu buat macam ni, kalau kita tengok dekat sini, ni sebenarnya dah bagi jawapan. Dah just change the position. Tapi bila kamu cuba pindahkan macam ni, kamu pindahkan 50 ni ke bawah, yang ini masih lagi 1 over T. How to change that? Terbalik kan? When here terbalik, jadi T over 1. Automatic yang ini pun akan terbalik. It becomes 120 bahagi 50. So, T equals to 0.417 second. Kalau risau kan, bila equation macam ni, when you feel, oh, is it true or not? Just substitute back all the information that we have into the equation itself. Are you going to get the same value? Ke tak dapat? So, kalau tak dapat, this is wrong. Senang je. Ni counter check, okay, untuk dapatkan the value of T. Okay. So, that is an example of how we use what we call it, velocity, speed, and also distance in solving some problem in linear. Okay, so now let's take a look a bit about angular case. Okay, tadi kan kita ada case angular yang macam jump. Okay, now let's see yang kicking bola tadi. We take, okay, kick bola. Okay, this is 0. So when he pull back, it is 190. And when he kick the ball, we assume it 0 again. So here, from point A to point B is 190 degree. From point B to point C is another 190 degree. Okay, let's say this action take 1.5 second. So what is the angular velocity? Okay, so when we talk about angular velocity, linear velocity is equals to, equals to distance over time. Okay, so angular velocity, benda yang sama, it is distance over time. But distance in angular is known as theta. Okay, ni nama dia, theta. Ataupun theta ni dalam unit degree. Okay, and velocity in angular is known by this thing. This symbol representing a figure known as omega. Okay, so when we talk about angular velocity, it is omega equals to degree over time ataupun theta over time. Jadi dekat sini berapa dia punya distance or displacement dia? It will be 380 degree over time 1.5 second. Berapa kita dapat? Oh, ada message ke? Oh, sorry. Dia tak share tadi. Tu ni. Okay, in angular, velocity is known as omega. Okay, it is known as omega. Macam W terbalik ni. Ni nama dia omega. Distance or displacement in degree in angular is known as theta. Ni lambang dia. Bulat slash. Bulat slash theta. Kadang-kadang kamu jumpa macam ni. Bulat atas. This is pi. These two thing, okay, ni theta. These two things is actually equal. Ini pi ni distance in linear meter. Theta ni displacement in linear. So kadang-kadang dia tegak, kadang-kadang dia singit. These two things serve the same thing. Okay, degree. Alright. So kita ambil yang ini. Kita ambil kaki ni. It start from 0, swing back 190, kick 190. So we know that the full action for one kicking is 380 degree. This is the distance covered by the tide. Okay, and this distance covered take time only 1.5 second. So how fast does this leg move? Kita carilah dia punya angular velocity equals to 380 degree over 1.5 second. Bahagi 1.5.
253.3.
Ya, 253.3 apa? Kalau linear tadi meter per second. Angular, since kita pakai degree, dia akan jadi degree per second. 253.3333 means that this leg move at a speed of 253.3 degree per second. Maksudnya dia bergerak daripada point sini sampai point sini selaju 253.3 degree per second. Every single second, this is the movement that's going to happen. Linear ke depan. Angular, berapa banyak rotation tu terjadi dalam masa tu. That is angular velocity. Okay. Katalah kita main softball. Kita main volleyball. Okay, kita nak spike. Okay, we try to spike a ball. Okay, we try to do a spike. So our hand will move like this kan, daripada bawah ke atas selaju mungkin. Okay, let's say tangan ni jarak ni, okay, this jarak, the distance, the theta for this movement is let's say 320 degree, and this movement occurs in 1 second. So how fast does this hand move? So kamu akan dapat omega equals to degree over t equals to 320 over 1 equals to 320 degree per second. Katalah kita ada player novice pula, the same action, but instead of 1 second, this player take 1.8 second to do the same exact movement as the expert. So what is the speed of the hand? What is the omega of the hand? What is the angular velocity of the hand? Kita tengok angular velocity novice equals to 320 degree over 1.8 second. Berapa kita dapat yang kedua?
177.78.
177.78 degree per second. Now, just an increment of 0.8 second tak significant pun, yet the speed being reduced. Maksudnya tangan dia ni lebih perlahan, separuh kali ganda lebih perlahan berbanding tangan expert. And this is some of the thing that you need to actually show in your presentation. Ni penggunaan angular dengan linear velocity. Okay, dapat tangkap sampai sini? Is it okay with you? We have distance, we have displacement, linear and angular. Now we have angular velocity in term of omega. Linear velocity lah V. Okay. And all of velocity belakang ni dia kosong, Pak. Means that it is actually 1. Kamu kena ingat ni. Kenapa dia kosong? 1 kita tak tulis. Because after this, we are going to discuss about acceleration. And when we talk about acceleration, dia akan ada nombor 2. And you need to write it out, or else acceleration akan jadi velocity. It give a different meaning. Okay, so this last part is regarding acceleration. Okay, linear and angular acceleration. So for acceleration, kaitan dia is with velocity. Mana saya punya tempat contoh-contohan. Okay, so we have acceleration, percutan. And acceleration, dia tak ada skala. It has value only in vector. Means you are going to have a positive acceleration, you are going to have a negative acceleration. And those acceleration give 2 meanings. 1, positive acceleration showing a case of acceleration, means increment of velocity, increase velocity. Or it is showing that the acceleration is moving upwards. Ni 2 maksud. 1, 2. Negative acceleration show a case of deceleration or a decrement of velocity. Or the second one show an acceleration downwards. Ni 1 benda, 2 benda. Ini adalah vector acceleration. So acceleration can be described, okay, in term of linear. Dia adalah A. Okay, acceleration saja A equals to velocity final minus velocity initial over time final minus time initial. While angular acceleration, dia macam A tapi dia ada echo sikit. This is known as alpha equals to linear velocity V, angular velocity omega. Jadi equals dia ialah omega 2 minus omega 1 over T2 minus T1. Jadi unit dia ialah meter per second square ataupun meter times second negative 2. Untuk angular, we have degree per second square ataupun it can be degree times second negative 2. These are the units for both linear and angular acceleration. Okay, let's take a look at the note first. Okay, define linear acceleration can be defined as the rate of change in velocity or the change in velocity occurring over a given time interval. Okay, and another way to express change in velocity, inilah tadi. Final velocity minus initial velocity over the change of time. Okay. So, let's take an example. Okay, apa itu acceleration? Okay, let's say kita ada same case lah. Kita ambil bola. And this ball travel at 2 meter per second. Dia tengah bergolek ni. It bergolek at 2 meter per second. And then somebody kick the ball harder. So it give an amount of force to the ball, which makes the ball now travel at a different velocity. So we can name it, ni velocity awal V1, ni velocity akhir V2. And this change occurs in 1.5 second. So what is the acceleration value? So kita akan ambil V2 minus V1 over the change of time. So 15 minus 2 over 1.5. Apa kita dapat? 15 minus 2 divide with 1.5. 8.67 meter per second square. Ni contoh. Okay, this is an example of acceleration case. Ni satu lah. So we take a positive acceleration. Okay, now let's say we have a ball travel at 15 meter per second. Okay, and then suddenly somebody block the ball. Means we give force in different direction, which cause the ball now to travel at 3 meter per second. Okay, and this change occurs in 1.1 second. So now let's find out what is the new acceleration for this ball. So we have acceleration equals to V3 minus V2. Dia always yang depan minus yang belakang. Over T. So it is 3 minus 15 over 1.1. Based on here, you know that the answer will be negative. Okay, 3 minus 15 over 1.
Negative 8.
1.1 bukan 1.5, sorry. Ni 1.1. Saya salah tadi. So it will become
Negative 10.90.
10.90 ataupun 10.91 di situ. Okay. So negative 10.90 meter per second square. So it show that it has a negative value, which means kalau kamu nampak case macam ni yang belakang lagi kecil pada yang depan, dia akan dapat negative. Means the velocity will reduce. If you have positive value, means the velocity will increase. Ni acceleration. Acceleration show how much change in term of velocity. The rate of change. So if the rate of change is small, means ini kan kalau kita buat graph, okay, if we go with 100% pula, 100 meter analysis, you can have something like this. Kalau kita buat analysis 100 meter, 100. Okay, this is time, this is distance. Alright, let's say 10, 20, 30, 40. Okay, kita ambil 50 je. And then we have several time lah. Okay, katalah time 10 equals to 9 second. Time 20 equals to 17 second. Time 30 equals to 26 second. Time 40 equals to 33 seconds. And time 50. Lamanya ni. Sekejap. Ini dah macam time 100 meter. Sorry. 10 meter, it will be somewhere around 2 second, is it? Okay. 2 second, this one is 3.3. This one is 3.9. This one is 4.6. This one is 5.9. Okay. Itulah ni masa dia. And then we have a graph like this. 10, 20, 30, 40, 50. Okay. If we go for 100 meters sprint analysis, kadang-kadang kita akan jumpa graf macam ni, which show that when you have a steep inclination macam ni, okay, these two show an acceleration. If you have a decline, macam ni kan, ada decline, this is showing deceleration. And then if we compare acceleration 1 dengan acceleration 2, steepness dia ni lagi steep daripada yang ini. Means that acceleration 1 ni is larger compared to acceleration 2. Okay. So now let's try to find out berapa velocity yang ada dekat sini. Let's try to find out that first. Okay. Okay, let's take the first section, 10 meter. Okay, so velocity 10 equals to distance covered 10. Time taken 2. So dia punya velocity 5 meter per second. Okay, velocity 20. Berapa distance covered dekat sini? 10 sampai 20. It will become 10. Okay, it will become 10. And time taken for this, berapa masa yang diambil dekat sini sahaja? Dekat sini sahaja. It will become 3.3 minus 2. 1.3. Okay, berapa kita dapat? 10 bagi 1.3.
7.69.
7.69.
69.
Okay. Meter per second. Okay, the third one, V3. V30. Okay, kita ada 10 meter lagi. And the time is, berapa masa? Berapa perubahan masa dia? 5.9 minus 3.3. Kita ada berapa tu? 6.
0.6.
0.6. Ni 3
3.
Okay, 0.6.
3.9.
0.6. Oh, laju gila kan? Berapa dapat?
Dapat 16.67.
16.67. Kita kena betulkan graf kejap lagi. Okay, V40. 10 over 4.6 minus 3.9. Berapa dapat tu?
0.7.
0.7. Okay. So, slow sikit pada ni. Berapa dapat?
14.28.
28. Alright, and finally V50 equals to 10 over 5.9, 1.3. Okay, berapa? Oh, ni sama, 7.69. Okay. Kita dah ada value for every single velocity. Now, let's recreate. Means we have some flaws at the pictures. So, let's recreate and we are going to see some acceleration value later. Okay, so we have something like this. This one will be the velocity. Okay, so velocity yang pertama 5. Velocity yang kedua 7.69. Velocity yang ketiga 16. Velocity yang keempat is 14. Velocity yang kelima is 7.69. So you are going to have this kind of performance curve. So based from here, kita ada berapa banyak acceleration dekat sini? How much acceleration do we have? 5.9 acceleration. And then 5.9 becomes 7. Ni pun acceleration. Ini pun acceleration. And then we are going to have deceleration. Deceleration. Ni based on features, based on pictures. Okay, now let's prove that on equation. Okay, so kita ambil acceleration 1. Acceleration 1 sama dengan V2 minus V1 over change of time. Okay, acceleration 1 dekat sini. V2 dia dekat mana? V2 dia dekat sini. Ini V2. V1 dia sini. Pasal ni kan graph velocity, so it start from 0. So we have 5 minus 0 over time taken for the first section. The time taken for the first section is 2 seconds. 5 bagi 2. 2.5 meter per second square. Okay. Acceleration 2. V2 minus V1 over time. Now V2 dia ialah sini. 7.9. 7.69 minus V1, 5. 7.69 minus 5 over the time taken for second section. Berapa second section ni? 3.3 minus 2. 3.3 minus 2. So, apa dapat? 7.69 tolak 5 bahagi dengan 3.3 tolak 2, 1.3. 2.07. Dapat?
Betul, betul.
Okay. So, here pun kita dah prove 4. Ni lagi steep daripada yang ini. Okay. This one is 2.5. This one is 2.07 in term of acceleration. Okay, now the third one. The third one yang ini akan jadi V2, yang ini akan jadi V1. So, we have acceleration 3, 17.67, is it? 16.67. 17 lah. 16.67 minus dengan 7.69 over the time is 3.30. 3.9, 3.3, 0.6. Okay, berapa dapat?
14.97.
14.97 meter per second square. And we go to acceleration number 4. Ni. So, acceleration number 4 is 14.28 minus 16.67. Dah dapat negatif dah. 14.28 minus 16.67. Tengok nombor ni pun, you know that the figures is going to be negative. Okay, bahagi dengan 0.7. So, the answer here would be negative. Berapa negatif berapa ni?
Negatif 3.41.
41 meter per second. This is the resemblance of graf yang menurun. So, bila kamu buat graf, whenever you be given a graph, it is shown an increment. So, most of the time, the acceleration will become positive. If the graph showing a deceleration trend, and then the figures will become negative. Okay, ni saya nak provekan je lah. And then another one, the steepness of the increment or decrement showing the magnitude. If the line is too steep, means that the increment is large. But if the line is quite shallow, means that the increment or the decrement is small. Ni acceleration. Okay. Let's try another example. Satu lagi acceleration. Okay, katalah kita ada, we have a wheelchair. We have people sitting on a wheelchair, and the wheelchair roll down a ramp. Okay, it roll down a ramp. Let's say this fella start and end. It takes only 3 seconds. Okay, it takes only 3 seconds for this fella to accelerate at a value of 20 meter per second. Okay, this fella fall down a ramp, and after 3 seconds, this fella had already reached 20 meter per second square of an acceleration. If it start from 0, what is the velocity of this wheelchair at the end of the ramp? Jadi velocity awal dia kosong. Velocity akhir dia, we don't know. How much is X? So, X is V2 minus V1 over change of time. V2 kita tak tahu, V1 dia kosong because it start from 0. Acceleration value is 20 and the time taken is 3. Dapat tak tu? 20 sama dengan V2 over 3. So, V2 sama dengan 20 kali 3. 60 meter per second. That is the velocity value of this wheel-bound person, okay, wheelchair-bound person at the end of the ramp. Ni acceleration dia. Ni antara penggunaan lah. So, kalau macam kamu buat pengiraan later on, let's say you go for a ball kick. Okay, ball kick, kicking a ball. Okay, so you try to swing the leg. Swing the leg. Berapa laju kaki tu? Tu pun acceleration in term of angular acceleration. Okay, how fast does the leg swing? Okay, let's say we start our leg, kita buat satu swing je. We go with one big swing from here forward. Okay, so let's say if omega 1 for this leg is 0, okay, and this action end up with omega 2 equals to 7 radian per second. Okay, and this action occurs in 1.2 second. So what is the acceleration of the leg? What is the value of the acceleration at the hip? Dia selalu tanya kawan tu, pasal dia akan cerita benda yang bergerak saja, which is your angular part. Okay, what is the acceleration value of the hip if unmovable leg, okay, become 7 radian per second under 1.2 second. Okay, ingat tadi, angular kita boleh cerita in term of degree, in term of radian, in term of revolution, in term of rotation. So kalau dia bagi radian, pakai saja. So it will become omega 2 minus omega 1 over time. Okay, omega 2 is 7, omega 1 is 0, time is 1.2. So alpha value equals to 7 over 1.2 second, and the value is 5.833 radian per second. Okay, so 5.833 radian per second ni berapa degree? To change radian to degree times, okay, value times 57.3. If to change degree to radian, value divide with 57.3. Macam sekarang kita dapat radian, nak jadi second. So 5.833 times with 57.3.
334.2309.
334.2309.
2309.
23 je lah. Degree per second square. So that is the acceleration value of the leg. Ni cara untuk kita gunalah, and this is actually what you need to have in your presentation. Okay, in term of kinematics. So you need to show distance and displacement, you need to show velocity and speed, and finally you need to show angular acceleration and also linear acceleration. Okay. Sekejap Okay, saya perlukan satu slide ni. Kita ambil ni. Alright. Now we have linear, we have angular. Okay, kita ada displacement dekat sini. Kita ada displacement juga kat sini. Okay, slash distance. And then we have velocity, V. Dekat sini kita ada angular velocity, omega. And then we have acceleration, A. Kat sini kita ada acceleration, alpha. Okay, sini kita ada meter, sini kita ada theta. If we try to have we try to have the relationship between linear and angular, we need to add on one other properties to all. Okay, properties yang kita kena tambah is this one. If we try to have linear and angular displacement, in relation, distance always equals to r theta. Kita kena include r. Velocity always equals to r omega. And acceleration equals to r alpha. This r is the radius of rotation. Yang lain semua sama. Okay. Example. Kita ambil satu example kat sini. Okay. Kita ada satu bat baseball. Okay. We hold it here and we have two different contact point. Okay. If we swing the baseball bat, this will be the resultant. Okay, ni jarak ni. Ini linear. Ini ada axis of rotation. Ini ialah angular. So, katalah kita namakan yang ini A and B, yang ini ialah X and Y. So, X, okay, X ni equals to R A. Okay, distance ialah R and A. Ni dia kena ada, kita kena masukkan dia punya R, axis of rotation. Y sama dengan R B. Okay, kita kena masukkan axis of rotation. Okay. So, apa yang berbeza kat sini? Radius berbeza. Radius 1 dengan radius 2. Means, with a similar angle, okay, with a similar angle, if we go with radius A, kita akan dapat pergerakan X. If we go with radius B, kita akan dapat pergerakan Y. Okay, kita akan dapat pergerakan Y. Oh, ni kita dah tulis A dengan B. Sorry. A dengan B tu radius. A, B, theta. Okay. Contoh. Katalah kita ada theta dekat sini, 20 degree. Okay, now, when we go for any relation between linear versus angular, the unit for angular need to be in radian. Okay, katalah, okay, theta dekat sini, kita ambil yang paling mudah je, 57.3 sama dengan 1 radian. Now let's try to prove this. Okay, radius dekat sini 1 meter, radius dekat sini 2 meter. Now let's prove X and Y. Okay, so X equals to A, 1 times with 1 radian. Kita dapat 1 meter. Y sama dengan B, 2 meter, kali dengan 1 radian. Kita dapat 2 meter. So, this one prove that linear value increase accordingly with angular value. So, if we increase the angular distance or displacement, accordingly, we are going to increase the linear outcome. Same goes with velocity. Okay, velocity dia macam ni. Okay. Okay, kita ambil volleyball tadi. So, volleyball. Now, let's say this hand, okay, this hand travel at angular velocity of 10 radian per second. Okay, and this hand, the radius, katalah daripada tangan ni sampai ke axis of rotation, this one is 1.3 meter. Okay, ini radius dia. So, R equals to 1.3 meter. What is the speed of the ball? What is the velocity of the ball? So, based on here, what you have is, this part is an angular part. And this part is linear. Is linear. So kita ada perumpamaan. We have V equals to R omega. So kita cuba untuk cari V. Berapa laju bola? That is linear. Yang dia bagi speed of the hand. So we have 1.3 times with 10. 13 meter per second. These are the speed of the ball. Nampak? Ini adalah dia punya apa ni? Relation between linear and angular. Untuk acceleration tu dia lain cerita, because when we talk about acceleration, when we talk about this v2 minus v1 over t, if we try to have this one in term of linear, dia akan jadi 2. In term of angular, ni linear, in term of angular dia akan jadi tangential A equals to V2 minus V1 over T, sama. And then kita ada acceleration radial equals to AR, AT equals to V2 over R. Jadi yang ni kita akan biar dululah. Okay, because for your particular plate, for your particular level, you are going to end up at linear and angular kinematics, not interrelated. Okay, these two are an extra information for you. Okay, relation between velocity and omega, so we need to add on R. Relation between linear distance and angular distance, we need to add on ni A dengan B ni, dia punya radius of rotation. Okay, ada soalan? Any question for today class?
Tak ada, sir.
Okay, alright, so with that, this will be the end of our class regarding kinematics, both linear and angular. So if you have any problem, please let me know later. I'm going to prepare some simple tutorial for you. You may have the tutorial, discuss and find out the answer before the end of the week. Boleh? Ni bukan paksaan, ni untuk kamu extra for you. Okay, so I'm going to give a week for you to discuss with your friend and come up with a question. Okay, so next week again will be week 11, your test week, and then please start doing your group assignment. So you may have all this information up until today inside your assignment. So next week we are going to continue with kinetic, and that will be everything that you need to have in your group assignment. Okay. Again, thank you for your participation. Don't forget to take your attendance. Assalamualaikum and very good afternoon to all.